Hello, this lesson is going to be on geometric sequences and just geometric sequences. If you want geometric series as well, you should watch the next screencast on that topic. As always with my videos, I'm going to try to go quickly, so please be ready with the pause button. So one of the first questions that you'll get when dealing with geometric sequences is being able to identify if a sequence is geometric, arithmetic, or neither. And so what I'd like you to do is I'd like you to take a look at this sequence, pause for a second, and see if it is in fact geometric. Okay, hopefully you've determined that yes, it is geometric, and it's because we are multiplying by 3 every time to get to the next term. So and it has to stay consistent. That's the reason why we call it the common ratio. We can't alternate. For example, we can't go times 3 one time and then -3 and then times 3 and then -3 or something like that. So it has to stay constant throughout the whole sequence. That's called the common ratio, and that's what makes this a geometric sequence. Okay, so now here's a slightly different question, and it asks us to show that it's geometric, and this is a lot more involved. So maybe it's not obvious immediately that this sequence is geometric. So what can we do to determine if it is geometric? Well, we can take the second term and we can divide it by the first term, and we get 5/2. And then what we have to do is we have to keep going. We have to check that the third term divided by the second term makes the same ratio, and that the fourth term divided by the third term, all the way down the sequence until you get to the end of what is given. And so if all of these ratios simplify and are equivalent, then this is a geometric sequence, and you've shown that it's geometric because you've shown that all the ratios are equivalent. And so a lot of students will ask, well, do you have to go through all of that? Do you have to show that every ratio is equal? And the answer is yes. You can't just do 5 divided by 2 and then assume that the rest of the numbers follow that same rule. You actually have to show that each one of them all make the same ratio of 5/2. And so that's what you're using to multiply to get from one number to the next. Okay, so now here's another challenge. I would like you to pause and find the numbers that go in the missing blank. Actually, the blanks are not missing, the blanks are there. But the missing numbers that go in the blanks, well, how do we do this? Well, it tells us that it's geometric, so that means that we don't have to show that it's geometric. We can just go ahead and determine that it's geometric by taking, and what the common ratio is we just take the second term and divide it by the first term, and that gives us, if we simplify it, 1/4. And so this is the number that we have to multiply by to get to the next term. So to get to this blank, we have to do 64 times 1/4. And so that gives us 16, so 16 goes here. And to go from 4 to here, we have to multiply times 1/4, and that gives us 1. So that makes the sequence 256, 64, 16, 4, 1. Okay, so let's use what we've learned to make a very important observation. And we're going to use this very odd looking sequence. I have some unknown number, we'll call it A. And what I'm doing is I'm going to multiply this term by r every single time to get to the next term. So we see that this is AR, and this is AR times r, which we can shorten to AR squared. And then this is AR squared times r, so we make that AR to the third, and we go on and on and on. So how can we find what the 11th term is? You might want to pause and see if you can think about what the 11th term would be. Okay, maybe it wasn't obvious. So what I'd like to do is I'd like to line up the number of the term below each term. So U1 is the notation we use for the first term. So the first term is A, the second term is AR, the third term is AR squared, etc. Okay, and now hopefully you can make an observation that the exponent is always 1 less than the term number. So the exponent of r is always 1 less than the term number. Well, there's no r here, Well, what is r to the 0 power? It's just 1. So that rule works throughout the whole sequence. So then what is the solution? It should be then that to get the 11th term, what I have to do is I have to take the first term and multiply it times r 10 times. So this is always 1 less than this. Well, let's expand. What if we wanted to know the 100th term? Well, we have to take the first term and multiply it times r 99 times. Well, now we should be able to generalize. Okay, so now what if we want to know any term of a sequence? The nth term. Then what we have to do is take the first term and multiply it times r n minus 1 times. Okay, and then this is our formula for finding the nth term of a geometric sequence. Okay, so there are a couple ways that this is written depending on what book you're using. So we will use this notation more commonly, but you'll also see it like this. So again, this is the nth term. This is the first term, the common ratio, and it's to the n minus 1 power. And that's our formula. And what we're going to do is we're going to use this formula to solve all of our geometric sequence problems. And let's take an example what that might look like. So let's have this sequence. And pause and see if you can find the 10th term. Okay, hopefully this was pretty straightforward. Now remember, you could always do this the hard way. You can always just multiply by 2 every single time until you get the 10th term. So you can do that. But and so if they ask for a term that's not too far down the line, like the 7th term or something like that, that might actually be easier. But if it's pretty far down the line, like the 10th term, we might want to use a formula. So let's use the formula. The first term, we can see the first term is 3 here. The common ratio is the second term divided by the first term. And that gives us 2. And we're looking for the 10th term. So if we substitute all these values into our formula, first term's 3, common ratio is 2. We have to do the 10 minus 1 power. And then when we simplify this, then make sure that you're following the order of operations. We have to deal with our exponent. And then we have to do 2 to the 9th first. That gives us 512, then times 3. That gives us our final answer. So the 10th term of the sequence is 1536. Okay, so let's take a look at this next example. This is out of our textbook on page 95. And the question is, how many terms are in this sequence? I'd like you to pause and see if you can figure this out. Okay, hopefully that was a long pause because this is actually a really hard problem and hopefully you were determined to get through it. Let's go ahead and talk about the answer. This is a little bit odd because it doesn't tell us how many terms we're looking at, but let's go ahead and review what we do know. We know that the first term is 2. We know that the common ratio is 3. And we know that the last term, the nth term, is 1458. So let's see if we can use our formula to find the answer. So here's our formula. We substitute these values in, including that the nth term is 1458. And then we start to solve. Well, we need to take this equation right here and solve it. I would divide both sides by 2, and then we get something like this. And then we're probably stuck. Now, if you know anything about logarithms, you can find the answer in 2 steps from here easily. If you're not ready for logarithms yet, then what we can do is we can guess and check. All right, and what we can do is just start guessing numbers that what n might be, and then take, let's say n is 10. So we can do 3 to the 9th power and see if that equals 729. Maybe that was too high. So maybe you guess 7. So 7 minus 1 is 6. 3 to the 6th power. Okay, and so on. And then the final thing that you can do is you can use your calculator. I'm going to show you that next. Okay, and you can use this trick for any equation, not just sequences and series. You can use this for anything. This is a great trick. So this is worth paying attention to here. So what we can do is we can take the left side of a equation and we can go into our graphing mode of our calculator, and we can choose y1 as the left side of our equation and y2 as the right side of our equation. You can always do this, and then what you can do is you can hit the graph button. You'll have to play with the window so that you can see both of the lines. So this line is actually the first part here. It's the 2 times 3 raised to the x minus 1 power. That's what this is. And then y2 is just this number, which is actually this flat line way up here at 1458 on the y-axis. So this window is actually very, very big. Very tall, very skinny window. Okay, and so what we want to do is we want to see where these two lines cross each other, because that's going to give us our answer. And so we have a command on our calculator where you can find the intersection point. And if you do that successfully, then you should see that at x equals 7, y is equal to 1458. That's the coordinates of this point. So x equals 7. That gives us the answer. Now, we're using x's here with our calculator instead of n's, but we should see that, you know, that's the same thing. So x equals 7, n equals 7 just means that our final answer is that there are 7 terms. The 7th term is 1458, so that means that there are 7 terms in the sequence. So that was a really challenging problem. So anyway, if you can do that problem, you should be able to do pretty much anything that they throw at you for geometric sequences. So thank you very much, and hope to see you for geometric series. All right.